Hello, good evening, guys. Can you hear me? Hello, hello. Good evening, guys. Good evening, guys. Can you hear me?
Hello, hello, yeah. Welcome back to the IOQM and problem solving session, guys. So let me share the screen with you. Let me do the problems with you guys. So yeah, welcome back, all of you. Perfect. So let's do the first problem today, and let me invite other people. In the meantime, I'm doing, I'm giving the problems with you. Just give me a moment. Okay, so yeah, good evening, good evening. Let me share the screen with you. Okay, with the problem. The first problem is this. It's let's do the geometry problem. I'm sharing the screen with you in the meantime. Can you see the screen? Can you see the screen, guys? Okay, perfect. Yes. So, perfect. So let's do this problem. It's a geometry problem based upon basic stuff. So let's do this problem. Okay, it's an important idea to do this problem, and let's see. It's an important way to look at this problem. As an important way. It includes a very important aspect of geometry. Okay, so let's see how we can usually mm, find the solution of it. So I'll give you a few moments to think about this problem, and In the meantime, let's yes. So the problem asks you to focus on suppose ABCD is square, E and F lies on side BC and CD respectively, such that V is equal to CF is equal to half of uh yes, hello Ramakrishna. Is equal to half of AB or the one third of AB. Okay. Now G is the intersection F and DE. If the area of ABGD is like by area of ABC, the actual square is M by N, value of M plus N. Okay. So it's a really basic problem to understand. So let's first do the diagram of the problem. Okay, that's it. Let's first do the diagram of the problem. Okay, so how should we do this diagram? So let's draw this diagram, okay? I hope all of you can see the picture over here. You need to make it a little more prominent over here. So this is the diagram over here. So this is A, B, C, D, say A, B, C, D, E and F are respectively so that BE is equal to CF is equal to one third of AB, okay? BE is equal to CF, BE is equal to F. Okay, so here is the one third position. Here is the one third position, and this is equal to one third of AB. Okay, it's easily understandable, and it's the intersection of E and BF and DE. Okay, so let's do this. Let's draw the diagram. DE and BF, and G is the intersection of this. Area of ABCD. ABGD, okay, this area is M by N, the ratio of the actual side with the actual, with the actual area of the triangle, okay, so of the square, okay. So we have to find this out, and let's see how we can use this to do this result, to find out the result, and you can use basic ideas about this similarity and whatever, I should not give it, I should give some time to think about it, guys. The ABCD square. Okay, ABCD is a square, and yes, ABCD is a square. A BF and a B is equal to CF is equal to one third of AB, so it's a one third of that side, and we joining BF and D to meet at G. Okay, so that area of this quadrilateral ABGD is how like M by N times the area of ABCD. So we have to find out M plus N. So let's try to find out. Let's try to find. Essentially, you have to find out how much ratio it is. Okay, so any ideas, guys? Any ideas? Okay, why is that? How do you get it, Sharmish Bastamalik? How did you get this one? Can you just tell me? Okay, so that's a very interesting aspect to this. So DF is to FC, DF is to FC is equal to 1. Okay. So this is an interesting observation. It's a very easy observation, but it's an interesting one to help us. So DF, it's 2:1 ratio. Perfect. 2:1 ratio. So how do you use it to find it? So what do you use it now? Like what do you exactly use it now to do this? Okay, so think about it, guys. Think about it. Okay, so you're trying to prove that BGE is similar to triangle DGF. So how does that help you in finding the area of the this region, this region? How does that find it help it to like? How does it help you to find you about that area? That's important, right? What is base division theorem? What is that? Sarthak Dobale. Yep. So people is trying to prove that in BGE and DGF is sort of are trying to be similar, but how does it use that to find the area of ABGD? That's important, right? How do you use that to find out? That's really important. So tell me your ideas, guys. Okay. So how did you find out, Sir Mr. Basamalik? Please tell me how do you find out? Give us ideas. So Ramakrishna has an idea. He tells that he draws a line parallel from G to mid AD, call it G dash. Okay, then let me listen to your idea first. We get the area of that thing are equal if after proving a similarity. I don't think so because the area must be twice of that due to the similarity idea. This is similarity idea. The area must be twice of that, right? If this is one, this lengths are twice of that, so it should be twice of that. If you are looking for that similarity idea. So what exactly you're looking for? Why are they similar? Yeah, that's why are they similar? That's my question is why are they similar? How do you rather find it out? Mm-hmm. Okay. So other people who are telling it's similar, how do you do it, guys? Just think about it. Think about it, guys. SIGBE sine, okay. Yeah, so that's unknown. So essentially you have to find out somehow, right? How will you find out? That's the question is all about, right? How will you find it out? How you're planning to find out? That's the question. Give ideas. Tan of FBC is equal to tan of EDC. Why is that so? Why is that so? Why do you think it's so? Let's try to calculate some area. So let's call it theta. If this is theta, okay, and then what do you know? This is 90 degree minus theta, right? This is 90 degree minus theta. What is this? This must be 90 degree plus theta, right? Right. And let's say this is phi, and if it's phi, you know, this is 180 degree minus phi. Since it's parallel, so this must be what? This must be something. That is, so it must be something what? Such that this plus this is equal to phi minus 90 degree before, right? It must be. So are they equal? It doesn't seem like to be they are similar, right? Right? Doesn't seem like it's similar. This theta minus 90 degree, then this is something else. This must be 180 degree minus 90 degree. Minus phi. Yeah, it does make sense totally properly, right? So how do you exactly find this stuff? See, I found the thing over here. I understand. So what's next? What do you think about it? Tell me. Yeah? Any ideas from your end, guys? How do you find the area of that stuff? Suppose it's 1, it's 2 over here. So how do you find the area? Any ideas? Do you want a hint from my side, guys? So I mean, someone gave me an exam, someone gave me a construction, okay? So let's do a little simple bit of construction over here. The construction is the following. Let's move everything out from here. Let's zoom in a little bit. Zooming in here, let's do a construction. The construction is this. Join G and C. If you join G and C, what will happen is the following. So let's assume that, yeah, so let's join B and D, let's join G and C. We need to join both. We know that, let's assume that it's 1/3 and 2/3. Here it's 1/3 and 2/3. Let's assume that the area of the side length of the square is 1, so it must be half, right? You can understand from here. You need to find this area, right? This area now. So how do you find it out? Yeah, you're right. So we need to find out BDG. BDG, right? So let's assume that this area, the following area is, let's assume this area is X, okay? BGE का area. And let's assume this area is Y. Okay. Therefore, EGC का area क्या होगा? EGC. Where is E? EGC का area क्या होगा? It's simple, right? If it's X, then it must be 2X. The height is same, the area base is twice of it. And if it's Y, it must be twice of Y, right? Of understanding? If it's X, this must be twice of X. If it's Y, it's twice of Y, right? Because the base is becoming twice of it. Are you understanding, guys? Perfect. Right? So what's next? What's next? What like? So we know something about it, right? So what information do you know? So what do you know about the area of triangle DEC and BFC? Area of triangle DEC and area of triangle BFC. Area of triangle DEC is what? Twice y, 3y plus 2x. Area of triangle BFC is what? 3x plus y. Now DEC is what? Height is 1 and base is 2/3. It's 1/3 over here. And BFC is what? Height is 1, it's 1/6 over here. Right? Now can you understand what you have to do? Yeah, tell me your ideas, Sharmishta. I'm eagerly listening to you. So what's the idea next? What's the next idea, guys? You have got two linear equations in x and y. You have to solve x and y. So solve it, guys. Solve it. Solve it for x and y. If you solve it for x and y, you get the whole thing, right? You get thrice x plus thrice y. Right, guys? Solve it. Solve it. What is x and what is y? Solve it from here. X is what? Y is equal to 4x. How is it so? How is it so? Okay, yeah, I'm getting it. 3x plus 6x plus twice y is equal to 3y plus 2x. So 4x is equal to y. Yeah, perfect. So y is equal to 4x. 4x is equal to y. If y is equal to 4x, therefore what do we get? We get that 3x plus y, that is only 2x. So we may be getting this, that 6y plus 4x, that is y, is equal to 2 by 3. Therefore, you're getting that y is equal to twice by 21. Y is equal to twice by 21. X is equal to 1 by 42. Perfect, right? Y is equal to twice by 21. And x is equal to 1 by 42. Now, let us understand that, therefore, what is this area? It's thrice x plus y, right? We need to subtract this thrice x plus y area from the whole y area to get this area, right? So therefore, x plus y to x plus y, it's x plus y is 5 by 42. Five by 42, and therefore thrice x plus y will be, if you divide by 5, it will be 5 by 14, and 1 minus 5 by 14 is the answer, that is 9 by 14. All the the solution, guys. Any doubts? Any doubts? All of you answer the solution idea. Hello, did you understand, guys? Did you understand this problem, guys? It's a very beautiful problem. After this, we'll be doing an interesting problem in there. Did you understand, guys? Okay, so why didn't you? Okay, we just solved these two equations, right? We got two equations of x and y, right? We got these two equations of x and y, linear equations. You can solve it, right, guys? Anand? Sure. I will repeat once again. So this is the problem all about. Okay. So what's the problem all about? The problem is all about this. So there is a square over here, and there are 2 points taken. So it's 1/3 of the whole thing. Okay, it's 1/3 and it's 2/3. It's 1/3 and it's 2/3. Okay, it doesn't look like 1/3. It should be the 1/3 region. Yes. And if you join this one, okay, if you join this one, observe that you need to find this area. So what we will do now is the following. Let's assume this x and you join this one. Okay, if this is x, if consider this one, if this is x and the height will be same, right, and this base is just becoming twice, so this one will be twice x, right? And if this is y, this one will be twice y, right? Tishika, did you understand this part? You understand this part, Tishika and Ahana? You don't understand this part. This is really important. And if that is x and twice, because the base is becoming twice of it, right? And this is how it's told it's 1/3. Let's assume all of the sides is 1. So therefore, what we get, we know that this, you understand, Ahana? So therefore, observe that we just calculate this area. This area is what? Height is 1 and base is 1/3. So this area is 2/6, 1/6. So that is BFC is 1/6 and BFC is what? 3x plus y. Okay. And similarly, consider this area. DEC, it's 1 into 2/3. Therefore, it's 1/3 area. 1 half into 1 into 2/3, right? So therefore, it's 1/3 area and it's twice x plus 3y. Okay, so therefore you get this from here, and so it's a two linear equations. You solve to get x and y. We got x is equal to 2 by 21 and y is equal to 2 by 21, x is equal to 1 by 42. And observe that what we need to find. We need to find this area, right? So essentially, if we can find this area, which is thrice x plus thrice y, that is 3 times x plus y. So let's find out 3 times x plus y. We found out to be 5 by 14. So therefore, this area must be 9 by 14 because the total area is 1. Did you understand, Ahana, Tishika? Any doubts? Any doubts, guys? Okay, guys, so let's move to the next problem. Okay, very good. So let's move to the next problem, guys. Next point is a counting problem. It's a combinatorics problem. So let's move on to that. This one is a problem. Can all of you see the problem, guys? So we have a number 1, 2, 3, 4, 5, 6, 7, 8, 9 can be rearranged to form a number that is divisible by 11. For example, 1, 2, 3, 4. These three are examples. How many such numbers are there? How many such numbers are there? That's the question. Do you understand the problem, guys? Any doubts in understanding the problem? Okay, so therefore think about, so the first hint is that think about the divisibility rule of 11. Think about the divisibility rule of 11. Perfect. So the divisibility rule of 11 is the following, guys. Sum of digits of even places, sum of even place digits minus sum of odd place digits is divisible by 11. Yeah, the 0 is divisible by 11. Okay, so that's the proof. That's the idea. 0 is divisible by 11. So try to think about this and try to understand what we can do over here. How we can rearrange this. Okay, so how many ways we can rearrange this? Think about this. Think about this. So yeah, any ideas, guys? So I've given you the first thing. Any ideas from your end, guys? Tishika, Ahana, Ramakrishna, Anant, Olivia, Sarmishta. Any ideas? Mayank, any ideas from your end? So any ideas from your end, guys? Um, the answer is no. The answer is not that. The answer is very long. So let's try to understand what is really happening over here, guys. Let's try to understand this very carefully. Yeah, so essentially, let's try to understand this. So essentially, what you're trying to do is that let's the even place का sum is x, let's odd place का sum is y. What is really happening? Wait a minute. Even ka is x and odd ka y. Okay, if you do this, and we are getting that x plus y is equal to what? Can someone tell me what is x plus y? Let's see. Let's try to understand what can be x plus y. X plus y is equal to 45. Perfect. X plus y is equal to 45. If x plus y is equal to 45, then what will happen? If x plus y is equal to 45, then essentially what you're trying to see, we are trying to see modulus of x minus y, right? It must be divisible by 11. 11 must divide it. So what can the maximum value of modulus of this? Maximum value can be 44, right? Not 44, yeah, 44, 43 actually. And the minimum maximum is this, okay? So therefore you can take 0, you can take 1, you can take 22, you can take 33. This is the possible values of x minus y, right? This is the possible value of x minus y. Right, guys? You understand this stuff? And if you understand this stuff, therefore let's take these cases, okay? When is x plus y, x modulus of x plus y is equal to 11. When it's not 11, okay? Let's try to understand this case. So observe that okay, so twice x is equal to 45. Why twice x, Anand? Okay, yeah. So you're totally right. So x plus y, x is cannot be equal to 0. X is cannot be equal to y. Because very good, Anand. Therefore, if x is equal to y, then 2x is going to be 45. Therefore, x cannot be equal to y. Okay, perfect. So can x minus y is equal to 11? Modulus rather. Can x minus y is equal to 11? If it's so, and given that x plus y is equal to, given that x plus y is equal to 45. Actually, what is this therefore? 11 divides what? Try to understand this. 11 divides what? 11 divides modulus x minus y. So y is what? 45 minus x, right? So therefore, it's twice x minus 45, right? 11 divides twice x minus 45. That's the question. So therefore, you can sort of assume that 45 minus twice x is the idea. Therefore, what values it can take? Therefore, x can take values not 0, right? Not 1. So what are the possible values of x? So can it take 11? It can take 11. It can take 33, okay? So therefore, let's understand this. X can be what? X can be, if it's 11, then it's 34, 17. And x can be, if it's 33, then it's this can be 12, 6. Also understanding this, guys? Did you understand this? So we have got it from here that x plus y is equal to, or let's say even plus odd, okay? Even sum plus odd sum is 45, you know, right? And we know that if divisible, 11 must be dividing even minus odd ka sum, modulus. This implies that 11 must be dividing odd is 45 minus e, that is twice modulus of twice uh yeah, twice e minus 45. You can also write it as 45 minus pi c. Okay. So therefore you can sort of understand from here that what are the possible values this can take. This can take 0, 11, 22 and 33, right? If it takes that, like, since x is greater than equal to 1, since it takes that, observe that therefore this is equal to odd minus even, right? So therefore this odd minus even must be equal to odd. So therefore these are the only two opportunities, 11 and 33. So let's remove this 2. If it's equal to 11, so therefore if it's equal to 11, e must be what? And 33 must be what? For 33, if it's 33, this must be 6, x e must be equal to 6. And here e must be equal to 17. You understand this part, guys? If e is equal to 17, then sum of even digits is equal to 17. 1, 2, 3, so so 9 digits there are.
Hello. Hello.
Right? So therefore what will be the case? Also that e cannot be equal to 6 because even digits sum 6 over there, 6 plus 8. So it all are distinct digits, right? So it must be 1, 2, at least 3. 3 must be there, but there are 4 terms, so it cannot be 6, okay? E cannot be equal to 6, E must be equal to 17. If E is equal to 17, then what? So therefore E is equal to 17, then x plus y plus z plus, so therefore what is the possibility of getting 17? X plus y plus z plus z dash is equal to 17. So this one, Yes, so this one must be equal to 17, right? So how is it possible using 1, 2, 3, 4, dot, dot, 9? So that's the question is all about, distinct digits. So think about it, think about it. So the only possibilities out there is, if you think about it, if you start with 1, let's see, if you start one of them is 1, then 16 is there. So 1, 9, 5. So observe that these are the only possibilities. 9, 5, 2, 1. Yes. 9, 4, 3, 1. What else? 8, 6, 2, 1. What else? 8, 5, 3, 1. 8, 4, 3, 2. 7, 6, 3, 1. Seven, 4, 7, 5, 4, 1. 7, 5, 3, 2. And 6, 5, 4, 2. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 options, right? And what else do you get? So it's also not true like this. There are other options also. We didn't get that thing. Observe this very carefully. Observe this very carefully now. So it can be other way around also. 45 minus twice E minus 45 can also be divisible by 11. How up till how much? So E come xm value can be what? E come xm value can be 7 plus 8 plus 9, 6 plus 7 plus 8 plus 9. That is 17, 24, 30, 30, right? And here it must be divisible by 11, so it must be 11 or 33. So this cannot be equal to 33, it can be equal to 11 maybe. So if it's equal to 11, then 56, then E can is 20 out, 28. So E is summing up to be 28 in that case. So there are two cases. E is equal to 70, E is equal to 17. In that case, there are 9 options and 9 such set, okay, and then we have to arrange. And so 4 over here. Essentially, from 9 set, essentially it's what? For 9 set, it's 9. For each of this, we have arrangement among the even digits into the arrangement among the rest of the digits. That is 5 factorial. This is for E is equal to 7. For E is equal to 28. For D is equal to 28, how many such summations are possible? Let's find out. For 4 digits, at least 7 must be there. So you can find out exactly 4 such possibilities are there. 2 possibilities are there, 9874 and 9865. That's it, simple. So 2 possibilities are there. So in that case, 2 into 4 factorial into 5 factorial. So therefore, 9 into 4 factorial into 5 factorial. Did you understand, guys? Any doubts, guys? because E is among 4 factorial for the 4 even place digits, and 5 factorial is actually the 5 odd place digits. Okay. So once you fix the 4 even place digits, the other 5 odd place digits are fixed, right? Not fixed, but the set is fixed, the collection. Now I have to arrange them. So it's 9 into 4 factorial into 5 factorial, because each of this set ke liye there is a different arrangement. All of you understood, Tishika? Ahana, did you understand? Did you understand it, guys? Okay, very good. Okay, so here it ends, and here it ends, guys. So that's it. So good night to all of you, and see you in the next session. Yep, and yep. So with more beautiful problems and much more interesting discussion. Okay. Good night and see ya. Bye bye.